is the solution to problem number 2 in homework number 19. Okay, so let's see. First, I want to recognize that this is a two-force member. We could attempt to prove that by noting that it has to have a force, or we could just actually just draw it down at the bottom and see that there's no way that it can support any kind of moment, right? There's a pin right up here, so the forces have to be up and down onto it. And so if we take a look and we split this thing in half right there, right, which you can see that this is going to be theta over 2, that direction right here. So we can see that this 2 is going to be theta over 2. All right, so let's zoom in down here onto this bottom of the leg. If we have a force coming up here, right, a normal force, we'll call this FNB. We're going to have a friction force. This thing wants to split apart this way, so the friction force has to be right in there. So that goes FFB. All right, so if this is a two-force member, and it appears that it has to be that way right here, then this force right here is going to be F. We call this BC because this is going to be labeled C, and this is labeled B. I forgot to label mine. I labeled A right there. Okay. So, and this is this is an FBD, and this angle right here is going to be my theta over 2. So we say the sum of the forces in the x direction. That was a pretty lame sigma. We could do better than that. Right there is just sigma. And we see that we have FBC times the sine of theta over 2 minus FFB equals 0. So let's just leave that for there for now. Then the sum of the forces in the y direction equal to 0. Positive being up. Let's see what we call those positive. We're going to have a negative FBC cosine of theta over 2, and it's going to be plus FNB equals 0. If we assume B slips first, and that's a pretty good assumption because he's standing over here on this side, so there's probably going to be more normal force on this side than there is this side. So there's going to be less friction right here. There's going to be more friction over here and less friction over there. Then we're going to say that FFB is equal to mu FNB. Right? So we can see here that FB is going to be equal to this. Right? So we say FB sine of theta over 2, right, is going to be equal to mu. You see FNB is going to be equal to this. I should have wrote BC here. There should be a BC. BC times the cosine of theta over 2. So these cancel out right here, and we get the tan of theta over 2 is equal to mu, which is equal to 0.35. Therefore, theta is going to be the inverse of 0.35, inverse tangent, 0.35 inverse tangent, 19.29, but times 2. So that comes up 38.58 degrees. Now, we want to confirm maybe our assumption up above. So if we take and only take this part of our free body diagram, and we want to make sure that we're putting this in here correctly. Here's going to be our FBC, and here is theta over 2 and theta over 2. I'm going to move my keyboard over to the side so I can slide this paper up further. Okay, and we have these guys coming in right in here. And we have our dude standing right here, right above and grabbing a hold, and his weight is coming downwards like right there, right? Here's our weight, and here's our FNA and FFA, and this is an FBD, X and Y in that direction. Okay, so let's say we do the sum of the moments about A is equal to 0, and we're able to figure out what FBC is going to be. So that's going to be counterclockwise. It's going to be what we could do is we could use the length of this thing if we can have what the component is that's right there. So that's going to be the sine of theta right there, what we just found out, and times the length, right? So that's the total length of the thing, and it's going to be minus this guy's weight and then that distance that he is at right there. So weight, and they call that xg, I believe, right there. Yes. And that's equal to 0. So we can say that FBC times the sine of 38.58 times the length, which is 8, minus 150 times 0.75 equals 0. We get FBC. So that's 150 times 0.75 divided by 8 divided by 38.58 sine I get 25.55 right here. And let me see here. Then what we'll end up with in the sum of the forces in the x direction equal to 0, we would get FFA minus our FBC 25.55 right here. I just want to double check on something here. I don't know if I like that. I don't like if I like my answer. I think it's going to be okay. But this is going to be the cosine of theta over 2. So it's the cosine of 38.58 over 2 equals 0. So my FFA is equal to wait, sine. Darn. Sine of 2 divided, and then take the sine and take 25.55. So we get that it's 8.44. Oh man, I don't like that. I don't feel comfortable with this. Let me see. I think I messed something up right up here. Let me try this again. 150 times 0.75, right, divided by 8, that's a very small number, and then 38.58. Okay, 38.58 times the sign is my, what's even smaller? Oh, I gotta divide. I gotta divide by that. 150.75 times 8 divided and a 38.58 sign divided. I get 22.55. Well, that's even worse. $22.55, huh? Okay. And so now in the x direction, we're going to get 38.58 divided by 2 and take the sine of that, multiply, I get 7.449. But I don't like this because my friction force is going to be let me pause. Okay, so let me go in the normal y direction. So the sum of the forces in the y direction equals 0, and we get FNA minus the weight of this dude, 150 up here, and then we're going to go plus FBC 22.55 and the cosine of 38.58 over 2 equals 0. And I get F NA. I'm just going to go down to another piece of paper. I'm trying to cram it all into here. F NA is equal to 150, 22.55, but I want to take 38.58 divided by 2, take the cosine of that, times it, but I'm going to subtract that out, and I end up getting 128.7 pounds, right? And so, like, finishing up on this, we see page 4 and 2 continued that what we would find here is the FA to slip is going to be this times NA, so it's 0.35, and times our 128.7, and so that's going to be 0.35 is 45.05 pounds. So it needs to be greater than this. The friction force needs to be greater than this in order for this thing to slip. Therefore, since B slips first, and the answer is going to be that theta max is equal to 38.6 degrees. And that's all she wrote.